All right. Okay, polynomials. So the word polynomial actually has like a meaning in itself, right? So poly, right? Poly actually means many. It's a Latin based, right? I guess root, or what do they call it? A prefix at the beginning. Poly, right, means many. Okay, and then nomial, right? Does anyone know what like nomial could be relating to? It's also Latin. Numerical, that's a good guess. Okay, so nomial actually means a name. All right, so the word is supposed to mean like many names. Okay, now in math though, right, that the names part, actually what we end up using, we say that it is many terms. All right, and I'll explain like what a term is. Yeah, it's a part or a piece, right, of the polynomial. All right, so an example, right, of something that is a polynomial. All right, and you've seen polynomials many times before. All right, so x plus 7, right? That's actually a polynomial. All right, so is 9x to the third minus 2x squared plus 1. All right, and even just one piece, like something like negative 5x, all right, that in itself is actually a polynomial. All right, it's not a big polynomial. All right, it's a very short polynomial. All right, but it is a polynomial. Okay, so to kind of get or create like a definition, right, of what a polynomial is, all right, let me show you something that's not a polynomial to like compare it with. Okay, all right, this would not be a polynomial. 9x minus 3x to the negative 2 power plus 5, all right, is not a polynomial. So what's something that's different, right, about this one than like all these other three that I put down? The what? The negative exponent, right. All right, so a polynomial, all right, a polynomial has to have a positive exponent on its variable, right? So in all of these, I used x as the variable. It could be any variable, right? It doesn't have to be an x, but the x does have to have a positive exponent, all right? That's part of the definition, all right, of a polynomial. So this one is not a polynomial. All right, now another thing, okay, and this, even the number 9 or any number, all right, I've used 9 a lot. Let's use like 3. All right, the number 3 is also technically a polynomial. All right, yeah, it is. All right, in itself, okay? Even though there's not an x or a variable with it, there is. All right, so in the last unit, this came up in our logs and exponents unit because of the exponents part, right? But this 3, we can say technically has an x to the 0 power. All right, x to the 0 power is one of those invisible math rules. It's equal to 1. All right, so this is just a 1. This is equal to 1, and 3 times 1 is just 3, right? You technically don't have to write this. All right, and so then you would just write it as the number 3. All right, and then but it's still considered a polynomial because, right, the definition of a polynomial is that you have a term, all right, that has a coefficient, all right, so all your terms have a coefficient. That would be the number that is in the front, right, of each of the variables. So like 1, even though it's isn't written there, there's a 1 in front of that. There's a coefficient. All right, this one, the coefficient is -2. That's in front of that x squared. All right, this 1 could also be considered a coefficient because there would be an invisible x to the 0 right there. All right, so that's a coefficient. All right, the -5 is the coefficient right there. Right, the 3 is technically the coefficient here. Then there's a variable. All right, oh, and I forgot the 7. The 7 is technically the coefficient, +7, right there. Okay, so there's a coefficient, there's a variable, and every variable has an exponent. All right, that's what makes up like a term. All right, a term has to have a coefficient and a variable with an exponent. All right, so this right here technically has 2 terms, right? There's 2 coefficients, there's 2 variables with an exponent. What's the exponent on this x? It's not a 0, or they probably wouldn't have written it. It's a 1, right? Another invisible math thing. Yeah, it has an exponent of 1. Remember, like x times x, right, is like you're doing an x to the first times an x to the first, right? And we'll multiply stuff with exponents like that, but it does have a 1, right? And they don't usually write the 1 there, all right? But they'll write any higher exponent than that, like 2 and 3 or 5 or whatever it is. This is also an x to the first power, right, with an exponent of 1, okay? So this is 2 terms, right? This polynomial has 2 terms, right? This polynomial has 1, 2, 3 terms, right? You can have polynomials that are really long with like 5 or 6 terms or more, right? We won't deal with those very much, but they do exist. Right, and this one here and the number 3 that I originally wrote, right, those are just 1 term. All right, so some of them, especially the shorter ones, like if they have 1 term, 2 terms, or 3 terms, all right, they have their own special names. 1 term, 2 terms, and I'm telling you this now, we'll actually write this down in another lesson on some notes, but I'm telling you this now just because I will naturally say them, right? And so you're like, what's that word that she's saying? Why is she saying that? So if there's only 1 term, it's called a monomial, all right? Mono is the like Latin monomial, 1 name or 1 term. Mono, like a monopoly. 1 person controls everything, right? That's the whole point of the game, Monopoly. Yeah. Right? Get control of like everyone else, all the money and stuff. All right. 2 terms. Does anyone remember 2 terms? Yeah, Ollie said it. A binomial. Right? Like bicycle, 2 wheels. And then trinomial. Binomial and a trinomial, right. Do y'all remember these words? I remember. Binomial and trinomial, at least. All right, yeah, 1 term. So anything with 4 or more 4 plus is just too many. They don't have they probably do have their own names, but I don't know what they are, right? But most people, anything with 4 or more, they'll just call it a polynomial. Quad, maybe. I don't know. That would make sense. All right. Anything with 4 or more, we don't really get as specific, right? And we're just like, there's a lot, so it's a polynomial, right? They're all technically polynomials, right, in the category, but we just don't get super specific and name it by the exact number. We're just like, there's a lot of terms, it's a polynomial. All right. Okay, does that kind of sort of make sense, like what the heck a polynomial is? All right. If it has any negative exponents, though, all right, if it has a negative exponent, it is not going to be a polynomial. All right, it would actually, I believe, end up being a rational function, and that's a different chapter. All right, that's not this chapter.
Different.
Yeah, different unit that we will study in Math 3, but we're not there yet. We gotta talk all things polynomials first. All right, I'm going to pass out. So we're going to start with adding and subtracting polynomials. All right. When you have like more than one of these, and they want you to either add them together or subtract them together, right? Pretty basic. All right, we will multiply polynomials and divide polynomials eventually, not yet, all right, but we're going to start with adding and subtracting. All right, we'll at least get that far today. So this is what your notes page is going to look like. All right, there's adding and subtracting on the top, and then there's multiplying on the bottom and on the back. And we'll see how far we get. Here you go. Here you go. 1, 2, 3. You're welcome. Okay, so adding and subtracting. All right, when you are adding, the nice thing is all you have to do is combine like terms. All right, when you add polynomials, all right, all you're really doing is combining like terms. I'm going to add a note over here for adding. All right, when you're adding, combine like terms. All right. The trickier one is subtracting. All right. When you subtract, when we're subtracting a polynomial, you can look at this like example number 3 right here. All right. The minus sign is in the middle, so it's doing this trinomial. Right, there's 3 parts to it, and they want you to subtract another trinomial. All right, what a lot of my students have done, and this continues to be something that I see a mistake on, is that they end up subtracting only the first term. All right, because the minus sign is right in front of that one, and they're like, oh, okay, so the minus sign goes with this one. Well, they want us to subtract the entire polynomial, which means that the subtraction sign actually goes with all 3 of the pieces. All right, so what you have to remember to do when subtracting only is you have to distribute the subtraction sign first. All right, distribute I'm going to call it the minus sign. just to abbreviate, distribute the minus sign first, right, only to the polynomial that comes after it, because that's the one that you're actually subtracting, right? Distribute the minus sign first, then you can combine like terms. Then it becomes just like an adding problem. All right, so we could say on adding, there's really just one step, right? Combine your like terms. They did add this, right? Write your answer in standard form. We'll talk about standard form in just a second. That one's pretty easy, okay? But because a lot of problems do say write your answer in standard form, just so you'll know how to do that, okay? But we're either just going to combine like terms or distribute the minus sign and then combine like terms, depending on the problem. All right, so if you look at number 1, all right, I can tell that it's an addition problem. All right, so we don't have to worry about any sort of distributing. We're just going to look at all the terms we have. All right, there are 1, 2, 3, 4, 5. There are actually 6 different terms there. We're adding together some trinomials. All right, and we're looking for the things that look the same, right? Combine like terms. Okay, I won't always do this, but this is a tool to like help you if you use different colors, and I would always let you, like different highlighters or pens or grab colored pencils or something, you can like color code like terms, like this 3x squared. What would be another term that is similar to it? The x squared, right? You're looking for the terms that have the same variable and the variable also has the same exponent, right? That's what's going to make it a like term. All right, so 3x squared and that x squared are similar. All right, the 11x, let's make this blue. So we have 11x and we also have a negative 5x. I would say those are like terms. All right, they both have an x to the first technically. All right, and then we have the positive 4 and the negative 13. Yeah, positive 4 and negative 13. They're both constants. They technically have an x to the 0 power, which is what makes it fit the definition of a term, right? So, all right, so we combined the same colors together. All right, how many x squareds is that? 2?
No, it's 1.
Yeah, the coefficient, or how the number in front of it, right, is how many there are. So there's only 1 x squared there, but we're going to combine it with the other 3 x squareds that we have over here. So now there are 4 of them, right? 4x squared. Okay, if we combine the x's together, it is a positive 11 with a negative 5. So you got to be careful there. Right? What's positive 11 and negative 5?
6.
Positive 6. Okay, so there's now positive 6 x's. All right, and then the numbers, when you put together the positive 4 and the negative 13, that's going to give you negative 9. Negative 9. All right, so this answer, our answer actually already is in standard form. All right, so standard form is when you order your terms going from the highest exponent down to the lowest, right? So in our terms, right, we have 3 terms, right? The exponent is a 2, right? It's x squared. All right, this one, when we have just an x, that's an x to the first power, right? So it goes 2, 1, and then we talked about how when there's no x written at all, it's technically an x to the 0, right? So if you order your answer going from the highest exponent down to the lowest, then that's writing your answer in standard form. So ours already is in standard form. All right, let's add a note right there. So it's like you order the terms from the highest exponent to the lowest. Right, from highest to lowest exponents. Yeah, not the numbers in front, right? So one mistake people have said, they're like, well, 9's bigger than 6, or or 6 is bigger than 4, so I should put the 6 in front. It's by the exponent, the little superscript, right, on top of the x, okay? All right, from the highest exponent to the lowest. All right, number 2. All right, number 2, we're also adding. All right, we've got, there's actually 1, 2, 3, 4 terms. So we've got a polynomial, and we're adding it with a 1, 2, 3 terms with a trinomial. All right, okay. That doesn't mean we're going to have 7 terms when we're done, though. Right? We're just starting out with 7 different terms that we're going to combine. Okay? All right. So let's see. Let's look at our first one. We have a 9n to the third power. Are there any other n to the third powers that we're going to be able to put that one with? No. I don't see any. Yeah, so that's going to be my only orange one. All right, what about a, we've got a negative 4 n squared. All right, any other n squareds we'd be able to combine it with? Over here, a negative 2n squared looks like there's another one of those. All right, then we've got some n to the first powers, technically, even though they don't write the n, the power of 1. It's invisible. So, all right, we got the 2 n's, and we can combine it with the, there's another 1 n over here. Yeah, the coefficient is invisible, but it's there. All right, and then the negative 10 and the 7 are both numbers, right? Some constants we can put together. All right, negative 10 and positive 7. All right, if you don't have anything to combine it with, then there's still 9n to the third, though, right? It's still there. It didn't go anywhere, right? It's got to be part of our answer, right? And our highest exponent does look like it is going to be the third power, right? So that's why I'm going to start with that one and put it in the front, okay? 9n to the third. All right, so now let's go down, right? So let's do the n squareds. All right, I have negative 4 of them and also negative 2 of them. How much together? Negative 6, right? It's negative 4 and then gets even more negative. So negative 6 n squared. All right. Let's see, a 2n plus another n to the first power is going to give us 3 of them, plus 3 n's. All right, and then negative 10 and positive 7 is going to make negative 3. All right, and our answer's in standard form already. We kind of made sure we did it that way, starting with the highest exponent terms down to the lowest. All right, and we got a polynomial answer. Now, here's the second one, or 2 and 4, all right, is where we're subtracting. right? These are pretty simple. Look for the things that are alike, color code them if you want to, put them together, right? Okay, this is where 3 and 4, here's where people forget, right? To distribute, we want to distribute the negative sign. All right, now I'm going to go ahead, even though nothing changes on these first ones, I just want to write it all on one line. All right, so I'm going to recopy down my 5k to the third minus 2k squared plus 2k. All right, and then I'm going to rewrite, right, these second 3 terms because I distributed the minus sign. All right, so I'm going to subtract 2k squared, or think of it this way, right? That minus sign is really a -1, okay, that's in front, and we're distributing or multiplying, right, each of these 3 things times -1. So if we do -1 times 2k squared, that would give you -2k squared, all right? -1 times this 2k would give you -2k, all right? And then this -1 times the positive 17, all right, would actually change it to -17. So when you forget to do that, it changes all your answers, right? Because then when you go to combine them, you don't get the right end number, okay? All right, so let's see, now we can go back and combine like terms. All right, so starting with k to the third. I don't see any exponent that's higher than that, do you? I think it's just k to the third. All right, do you see any other k to the thirds?
No.
I don't. All right, what about k squareds? Let's see, we've got this minus 2k squared and another, I see another minus 2k squared.
Oh, fun.
All right, then we have a positive 2k and a negative 2k. All right, and then the last thing is the -17, all right, but there's not another one without a that's just a number for it to go with, right? All right, so only the green things and the blue things are we going to be able to combine together. So the 5k to the third is by itself. We still have it there though, we still got to write it. It still has the highest exponent, so I put it at front. All right, a -2 and another -2k squared. So now how many are there? -2 and -2 put together. -4k squared. Nice. All right, +2. Oh. And -2. I know. I'll get my charger in just a second. Was +2 and -2? 0. All right, they canceled each other out. There's nothing. If there's 0 of something, there's nothing. And you don't have to write anything. There's no K's anymore. All right, and then last but not least, right, the -17 doesn't have anything to combine with, but it's still there. All right, so we got to include it at the end. All right, but yeah, there's no k to the first power term since it canceled out. All right, but this is in standard form, right? We go from the highest exponent, which was 3, down to the lowest, which is technically a k to the 0, even though we don't write it. All right, how about you try number 4? Try it. You got to distribute Don't forget to distribute first, then go back and combine your like terms while I get my charger and plug it in. Alright, I'm gonna freeze my screen so I can work it out on my paper, and then it'll give you some more time to keep doing it, and then we'll check our answer with each other. And you do want to try to put your answer in standard form. So start with the highest exponent to the lowest. You might have to just reorder. You might have the right pieces, but just need to reorder them. Right? You got it? You got something, huh? A polynomial? Alright. You got it?
I ordered.
Let's see what it is. Alright, here's what I got. I got y to the third in the front, a positive 2y squared, a positive 6y, and then negative 4 at the end. Right, and you can see, so you can see where I distributed. All right, so it made this 1 be a negative 1. It made the 2y squared be a negative 2y squared. Right here, this 5y was already negative. So when you multiply it times negative 1, a negative times a negative actually becomes a positive. Right? So it just switches the sign, right? It was all, these were already negative at front, so now they became positive. All right, and then I went back to see which ones to combine. there wasn't anything to combine the y to the third with, but everything else had something. All right. Yes? No? Yes?